All right, so basics 5 practice. All right, we got our general solve, your factoring problem. So obviously we got to shift everything left. Bad looking square. And we'll factor. I think I'm going to use 5x and 2x. Because 5x squared times 2x squared is 10x squared, and probably 3 and 1. 1 and 3, I think that's right. If we add 5 and take away 6, we'll be in business. So now zero product property, 5x minus 3 is nothing. X is going to be 3/5. Or 2x, what is that? Plus a 1 is nothing. Subtract 1, 2x is -1. X is -1/2. So there's your two equations to that bad boy. Find the zeros of x to the 4th minus 256 is factor it again. This is along the lines of an a squared minus a b squared pattern, which is a minus b times a plus b. And I know it takes an x squared to create x to the 4th. And I also know the root of 256 is 16. So minus 16 plus 16. This guy factors again. That's x minus 4 and x plus 4. And then we have x squared plus 16. So I have x equals 4 by using the zero product property and -4. And this guy requires that I set equal to 0. I subtract 16. I counteract the square by a square root. That is not real. It is imaginary. But it's 4i, -4i. Moving on to 3. 3 is your grouping problem, has been for a minute. Both pieces contain a 2x squared, cubed and squared. I'm left with x minus 7. X minus 7 must repeat. And to make this an x, I'm going to pull the -18. And I promise you that 18 times 7 is 100.6. So what do we have here? We have the common factor of x minus 7. The stuff left over is 2x squared minus 18. And those are both even. So I'm going to pull this 2 out to the front. And I'll have x squared minus 9 left over. X squared minus 9 being a dots pattern, difference of two squares. It is going to be x minus 3 and x plus 3. There's your complete factorization. Evaluate 1/64 to the -5/3. First thing we're going to do is we're going to flip the fraction. This is 64 to the 5/3. That's from that negative exponent, okay? That flips it. That's what it does. That comes from this rule right here. 1 over x to the negative n is x to the n. A negative exponent flips a fraction. We're going to view this as the cubic root of 64 that we turn around and raise to the 5th power. And you know as well as I do, 4 times 4 times 4 is 64. So this is 4 to the 5th, which is a pretty good size number. It's going to be 1,024. Moving forward, find the solution of this guy. You're supposed to be writing two equations. -3x minus 5 is less than or equal to 7, or positive 3x plus 5 is less than or equal to 7. We add 5, we get 12. We divide out the negativity, we get a sign change, so x is going to be greater than or equal to -4. We subtract 5 and we get a 2. We divide by 3 and we get less than or equal to 2/3. So, look at the context of this thing. Think about a number line if you got to. It would be 1, 2/3 would be about right here. We have equality. I am less than this guy, but it says greater than that guy. So I'm the space in between. I'm everything between -4 and 2/3. All right, so what's different about 6? Different on 6 is I decided I would make the whole blasted thing negative. Now think about -x squared. That's that, right? So we're going to pull out the -2 so we can factor. And we have a problem. I really need this to be a negative. So make that -12. No, I'm somewhere else. I'm somewhere else. Anyways, how do you want to make a 6? Probably a 2 and a 3, maybe? Yeah, 2 and 3. We need to be plus 10x and minus 3x to get that positive 7. All right. Now, our solutions are x equals 3/5 or x equals -2. You're supposed to think about the graph. It opens down. So at 3/5 we have an intersection, at -2 we have an intersection, but this time it opens down. This is the territory I want. I want the stuff between -2 and positive 3/5. So from -2 to 3/5 on this one. It's different depending on what it's asking, but you need to be thinking about your graphs. All right, use the decimal approximations, local max and min, determine intervals on which the function is decreasing. Now this, by the way, is 1/3. So we are decreasing from here to here. So we start at -infinity all the way to 1/3. And we're also decreasing from 3 on down. So 3 to positive infinity, because we're moving right. This is coming in from the left, right? So -infinity, vice versa. All right. The hardest one on here, at least I think these are the hardest. It would have been nice if I would have plotted that vertex for you. Looks like it's at 2,6. So this isn't as easy as you might think it is. I wish it was, but it's not. Pay attention to this, that A is 2 because we rose 2 and ran 1. All right, that's a big deal. You should also realize some things that have happened. We have to apply the order Bach. This is the horizontal stretch or compression, and we're not using it. So just focus on hack. All right, H first. Now what happened is we started at 2, and it didn't go anywhere. So when you talk about g of x, it's just f of x. When you're talking about h, okay? There wasn't a shift left or right. It stayed in the exact same place. Didn't go anywhere. That's good. Now we focus on A. 2 things have happened. A is 2, and it's also negative. It's negative from the reflection. It's a lot easier to show these with functions, okay? But if you just do a simple table, f of x is 6 when x is 2. I got this backwards. I don't know if I should show tables or not. Now I'm doing x and -2f's of x. What that -2 does is it multiplies y by -2, right? So x is still 2, but this becomes -12. Now, our outcome is to have 2 and -6 to be g of x. All right, that's our outcome. So something has to happen. I have to add 6. So what actually happens is we have -2 f sub x plus 6. Again, that is a y. That affects y. And this is the function rule. -2 f sub x adds 6. And I know that seems weird, so, and I know you're probably not even watching, but whatever. Let's just go to Desmos. So the original function, if you think about it in vertex form, is x minus 2 quantity squared plus 6. I'm going to graph that. Yeah, I think it was negative, wasn't it? Sorry, it's x minus 2. Like, what's wrong with me? And it's also negative because it opens down. So there's the original guy, 2, 6. Now, what I'm saying you do is you multiply the whole thing by a -2. And it's the whole thing. It's not just part of it. And let me zoom out, and you'll see where she's at. She's way down there. I need that negative symbol. But she's down there. So in order to actually look like the graph I have to shift it up 6. And let me turn this one off now and zoom in. And you'll see they're the same graph. See how we get really close to the origin there? We cross it 2, cross it 2, close to the origin. So it's not as easy as you want it to be. And I hate that for you, but it is what it is. Nothing I can do about that. The quadratic has a vertex at 4, -3. Determine the vertex of the quadratic after the transformation. G of x is f of x plus 4 minus 3. So this is a simple left 4. That's all it is. So if I'm currently, sitting pretty at 4, 3, and I go left 4, I'd be right here. So I'm at 0. This one I trust. It's down 3. So if I'm sure I was down here 4, -3, and I'd drop some more, right? -6. All right, determine the domain of x minus 4 over x squared minus 121. You have a rule for 1 over anything. The anything is not 0. So x squared minus 121 is not 0. The easiest way to do this one, by the way, pay attention to that, is to just shift the 121 over, counteract squaring by square rooting, and we're not plus or minus 11, because the square root of 121 is 11. So we're everything but plus or minus 11. All right, find the domain of the square root function. Similar rule, the square root of anything, the stuff inside is greater than or equal to 0. A couple of you guys put less than or equal to 0 on your last quiz, but it's about being greater than or equal to 0. So I do that because the smallest thing I can take the square root of is 0. So take the inside, compare it to 0. We add 28. We divide by the -4. Remember to flip your inequality. X is less than or equal to -7. That means less. Less is left. Negative infinity to -7 with a bracket again because of number line concepts. Less than. I'm running left. I'm running left to negative infinity. I think about a third of you guys have got the difference quotient down. It's not where I want it, but we'll just keep working on it. You'll get there eventually. So it says find f of x plus h. So every x I see is going to become x plus h, okay? 5 times x plus h times x plus h, because it's squared, minus 3 times x plus h plus 2. Now, if you'll do this about 5 or 6 times, you will realize what x plus h times x plus h is. So it's going to be x squared plus xh plus another xh plus h squared, which is 2 of those xh's. And every time you do x plus h times x plus h, that's what you get. It's always the same thing. Distributive property minus 3x minus h plus a 2. Distributive property again, 5x squared plus 10xh plus 5h squared minus 3x minus h plus 2. And I know it's a lot of writing, but I have this piece now, and I'm going to take it and I'm going to put it right there, okay? I have 5x squared plus 10xh plus 5h squared minus 3x minus h plus 2. And see what it says next? It says now take away the original expression. And it's all sitting pretty over h. Notice I wrapped. You have a 5x squared, take away a 5x squared. You have a negative 3x, take away a negative. That's addition. Gone, gone. You have a 2 minus a 2. Gone, gone. Whatever is here, this always cancels out. Always. No exception to that. It cancels out. So we're left with 10xh plus 5h squared minus an h, all sitting pretty over an h. And because I haven't done this in a while, I'll show you. If you pull an h from all 3 terms, this is why the h's cancel. You cancel out common factors. Redo the order here. We have 10x minus 1 plus 5h. All right, the bonus is find the slope when x is 10. You literally plug in a 10. We don't worry about this guy. And that's 99. Ta-da! Identify all the asymptotes of f of x. Of course, there are rules. There's 3 rules for your slant / horizontal. But long division always works. Plain and simple. So we're dividing by x squared minus 9. The dividend is 4x cubed minus 4x squared minus 3x plus 2. And I need a 4x so that because 4x times x squared is 4x cubed. And 4x times negative 9 is minus 36. I need to put that in a different spot, don't I? Minus 36x. Wrap before you subtract. This guy goes straight down. These guys cancel. Negative 3 minus the negative 36 is plus 33x. And we'll go ahead and bring down the 2. Now, for x squared to become negative 4x squared, I need a negative 4. So negative 4x squared plus 36. Again, you wrap before you subtract. And we're going to have 33x minus 34. And this is the remainder. And it disappears. So there is a slant asymptote at y equals 4x minus 4. That's a slant asymptote, all right? For your vertical asymptotes, the denominator is equal to 0 because they happen when we divide by 0. So x squared minus 9 is nothing. X squared is 9. X is plus or minus 3. 3 asymptotes. 2 vertical, 1 slant. No horizontal. All right, even and odd, still an issue. I don't know why, but it is. So you got your rules right here. Let's find g of negative x. It's twice a negative x to the 4th minus 4 times a negative x to the 2nd minus 3 times a negative x. So if you take a negative x and raise it to any even, it's going to be a positive x to the same even. It's just how it works. Because an x negative times a negative is a positive. So this is 2x to the fourth minus 4x squared, because this becomes positive, plus 3x, because this is to the first power. It's the only one of those we're actually kind of doing the distributive property. Now, is that the same as the original? No, so it's not even. This was the even rule. Not even. All right, now we're going to find negative g of x. Negative gx is when you take the whole function and you just wrap it in a negative symbol and you use the distributive property. So this piece becomes negative. This piece becomes positive. And this piece becomes positive. That is not equal to this. See the test? We compare these two. They're not the same, so it's not odd. It's neither. They differed here. One of them was negative, one was positive, actually, and here as well. Which is not the same. Restrict the domain so that f of x is 1 to 1 and find the inverse of g of x, blah, blah. So again, first off is your domain, restrict the domain. This guy is right 1, up 3, and it's a parabola. And we throw away this piece right here. So the domain is to go from 1 to infinity. First thing we do, find the domain. Now you write your inverse. We swap x and y. So this becomes x equal 4 times y minus 1 quantity squared plus 3. And then we just do the easy stuff. We take away 3. Then we divide by 4. Then we take the square root of both sides, and I'm going to do this as a fraction. Root of x minus 3 over 2 equals y minus 1. And it is technically, well, it's supposed to be plus or minus, but since we restricted the domain, it's just positive, and we add 1. Root x minus 3 over 2 plus 1 is the inverse of f of x. And we're supposed to think about the range of the inverse. Okay, that's a square root function. It's right 3, opposite sign, up 1, and it's a positive, so it opens up. All right. So the range is 1 growing to infinity. Three to go. Let f of x equal 1 over 2x minus 5 and g of x be 3 over 2x minus 6. Find f of g of x. So all of this is going right there. This one's a little harder than they have been. Don't forget about that minus 5 right there. Now, when I glance at this thing, I can look right here, and I can tell you 2x can't be 0. So x is not 0. That's pretty common on these. That's part of it. The distributive property kicks in. 2 over 2 cancels. That's going to be 3 over x. Oh, I'm going to distribute that too. 3 over x minus 12 and then minus 5. So 3 over x minus 17, all under 1. So since I can't divide by 0, 3 over x minus 17 is not 0. I add 17. I x both sides. So 3 is not 17x, and x is not 3/17. There's my two things I can't do. All right, the next part. Simplify your answer such that it is a unified fraction. So I'm sitting at 1 over 3 over x minus 17. And all I have to do is x everything. By x and 1, I get an x. If I do x times 3 over x, the x's cancel. And x times 17 is minus 17x. Easy peasy, lemon squeezy. Angle of 135 degrees lies on a circle of radius 6. I'm tired. What are the x and y coordinates? So here's what I know. I know that the sine of theta is y over r. Okay. If I'm at 135 degrees on the unit circle, I'm about right here. I'm at root 2 over 2, root 2 over 2. So on the unit circle, sine of any angle is y, and the cosine of any angle is x. So the sine of 135 degrees is, this should be negative root 2, is positive root 2 over 2, and it's equal to the y coordinate over the radius of the circle, which is 6. And to solve that, all I got to do is just 6 both sides. 6 over 2 is 3. Y is 3 root 2. Now, for x, I think about cosine being x over r. I start plugging in. Cosine is going to be this negative root 2 over 2. It's going to be equal to x over 6. And I do the same exact procedure. I 6 both sides. I get negative 3 root 2 is x. So my order of pair is negative 3 root 2, positive 3 root 2. Forgive me, I'm getting really nauseous and dizzy. I didn't sleep well last night. And I'm just trying to get this done real quick. Simplify sine of x times tangent of x minus cosine squared. And so show your evidence. Anyways, tangent is sine over cosine. So this becomes sine squared. I really want this to be a plus sign. Make that a plus of x plus cosine squared of x, which is just 1. So that needs to be fixed. That's cosine. Sorry about that. This is supposed to be a simple one. Then you have the rewrite as far as you can. Cosine divided by 1 minus sine. And what you're supposed to do is you're supposed to multiply through by the conjugate, which is 1 plus sine of x. I don't know that I would do anything with the top just yet. Bottom we FOIL. 1 times 1 is 1. We'll have a plus of sine x, and then we'll have a minus sine x. Sorry about my handwriting. Like I said, I'm getting nauseous. Then we have a negative sine times a sine, which is minus sine squared of x. Okay. So there's some identities out there. Sine squared plus cosine squared is 1. Cosine squared is 1 minus sine squared. This is cosine of x times 1 plus sine of x. Sitting pretty over cosine squared of x. Right? Have cancellation. 1 plus sine of x over cosine of x. You actually could take this farther if you wanted to. I'm okay with it looking like this, but you know, if you want to take it farther, you have 1 over cosine plus sine over cosine, which is secant, plus tangent, which is really, really good. It takes it from being a fraction to not being a fraction. So it's just secant plus tangent. And I think that's it. That is it. So there is Basics 4. Enjoy. You're welcome.